Hello viewers and friends, welcome to my channel BST African Electronic Surgery. Finally Wednesday, okay? So we have job here, but at first this wasn't our job. How can I explain this? At first the customer came to us looking for a new motherboard to buy, and you know what, if you get such kind of customers who came, you know, my laptop is dead, it's not working, I'm looking for a new motherboard, do you have any? The first question that I asked is, what happened to the one which you were using? He said, I went to 2-3 shops locally and outside the city, and they are saying one of the shop, the repair shop which I went, they said the processor is dead. You can see this note, 3 March 2023, 40 processor. I don't know which repair company is this, but the guy is coming from the second capital city of Zimbabwe, Bulawayo. He phoned me, he said, I'm coming to Gwanda, so I'm looking for a new motherboard because the one which I was using, they said the processor is dead. So I do have, of course we do have this kind of motherboard in stock, but I said, you know what, bring the old motherboard so that we can assess to see if it's true that the processor is dead. We are not here to judge anyone, but we are here to support good works and condemn anything which is bad from other technicians, okay? So that is told about this motherboard. It's HP 250 G4 motherboard, no power. So the customer didn't want this board to be repaired because already what they told the customer installed into the mind that this motherboard need to be replaced. Maybe, we don't know because I didn't check anything. So we need to redo the test and see what's going on with this motherboard before we can give customer another motherboard, because we do have another motherboard, a working one, but if this is going to be fixed, the customer will pay less instead of buying another new motherboard. So we have to put the diagnosis here and fix if this thing is fixable. That's what we agreed with the customer. So that's the thing. So usually I don't usually trust a job from any other technician. I have to restart the whole process again. So that's the motherboard. The motherboard looks nice. We have a metal thing, that the heat sink, no fan. You know those kind of motherboards. I seen some kind of this motherboard on Lenovo laptops. Everyone's doing fake things these days. Heat sink, no fan, okay. ENE, that is startup chip, SIO chip, microcontroller, whatever I call it. We have some coils, power supplies. We have the RAM, we have 4 gig DDR3, BIOS battery, some more connectors here, That the battery connector, we have the charging port is still there, no switch. Okay, so I think we have the charger. I think I do have the charger of this one. Let's test the charger first. Minus, plus. Check on the screen, 19.96. So our charger is good. With the HP motherboards, it's very easy. Here on the charging port, they put an LED here, which indicates if everything is okay, the LED will light. If the 19 volts power rail is okay, and the 3.3 is on, we must have light there. So let's plug. We don't have any light. You see? But we check the charger is good. So if we don't have any light, it means something is not right with the 19 volts power rail or the 3.3, which is always on. Okay, so what I would do, the charger is still plugged. Our charger is still plugged here. Let's check some voltages here. Ground from the USB ports, the plus on the charging port. On the charging port, we do have 19.96. So we don't have problem with the charging, with our charging port, okay? Because from this end to the motherboard, our 19 volts is passing through. So what is the next step? The next step is to identify those input MOSFETs. This first MOSFET, second MOSFET, the current sensor. So here I can't see anything. If I check on the other side, we do have this big MOSFET, a small MOSFET, and that's the current sensor. Maybe you can't see. That's the bigger MOSFET, second MOSFET, and the current sensor. So I'll check for voltage there. Input 19. We are checking the first MOSFETs. They are in serial mode. The input, we do have 19 volts. Output 0.89. You see? What about this pin? What about on the gate? 0.88. So the first MOSFET is not driving power, the 19 volts from the drain to source. So what can be the problem? I'll show you the secrets about these MOSFETs. Maybe we can draw something here. 1 second. I think we can draw something. Let's redo this thing. We've explained this thing several times. Let's draw exactly what is here. We do have our first MOSFET, 4 pins together. We have the 19 volts here, and that's the ground, the minus, and that's the plus 19. The plus 19 is going straight to this MOSFET, 4 pins together. That's our MOSFET, and 3 pins together, and we have our gate. What about the second one? The second one, 3 pins together, our gate, 4 pins together on the output, and after that we have resistor, current sensor. Okay, those are switches. Like I explained these are switches. What are they doing? They are cutting down the power in case of if we have any short or any voltage, under voltage, over voltage. They are there to protect the motherboard in case of any further damage. Okay, so this one is the first MOSFET, that's the second MOSFET, and our gate, which is going probably to the BQ chip, the charging IC, BQ. So here we have drain, 3 pins, that's our source. Here we have drain. We want to draw exactly what is here. So the first MOSFET, I'll check under microscope, which is not here. I want to see if what kind of MOSFETs are these ones. 6426. This one is 6426, and the second one 7506. Those are the number of the MOSFETs. So it's very easy to see if this is an N channel or a P channel MOSFET. So you check on the last digit, this one. If it's divisible by 2, it means that number is an even number. So any MOSFET with the last number that is divisible by 2, like an even number, that is an N channel MOSFET. N channel MOSFET. I explain about this, like 2, 4, 6 even numbers. So you identify any channel MOSFET by looking on the last digit. The last digit, if it's an even number. If it's an even number, this is the basic mathematics. Even number, odd numbers. Channel P MOSFET, P channel MOSFET, 1, 3, 5, 7. Those numbers which are not divisible by 2, odd numbers. The last number, if it's 1, 3, 5, that's a channel P MOSFET. So according to these numbers, what do we have here on the motherboard? We have 2 channel N MOSFETs. So the question is, why this first MOSFET? Here we have 19 on the drain, but the 19 volts is not passing to the source. Why? In most of videos you see me shutting down the MOSFET, and if there's no any other further damage, the motherboard will turn on. Obviously you have to understand what's going on, why the first MOSFET is closed. In some scenario, if the first MOSFET is closed and we check on the current sensor, maybe we can check. The multimeter is on 19 volts, the power supply is set on 19 volts. We can check to see if we have any shorted power rail there. We'll go straight on the current sensor. Let's skip those MOSFETs and see how much power is being taken by this motherboard. On the current sensor is taking like 13 milliamps, which is standby current. Check here. I release the power, there's no light. I put back the power, we do have light. You see? With the power supply, if I jump those MOSFET, I'm injecting 19 volts on the current sensor, and we just found the light. You see? Disconnect, no light. Connecting, we do have light. So we don't have a shorted power rail. So the question is, why the 19 volts is not shorted? So today we don't want I don't want to jump that MOSFET with a wire. We need to trace why the MOSFET is not driving that 19 volts. So I will take both the MOSFETs and we check them one by one. Let's take down all those MOSFETs. We want to check why. Maybe the second MOSFET is shorted. Because if there is no short, we must have 19 volts on the output. The first one is out. The second one is out. Now we have to check why those MOSFETs are like that. Diode mode. Let's check this bigger one, the first one. While checking source to drain, the bigger one looks okay. Let's check the second one, because there must be a reason why those MOSFETs, they are not driving the power. Check the small one, source to drain. It's like 0, 0. You know, the source, drain and gate combination should not be mixed up. I'm checking from drain to source. You see, the smaller one, the second MOSFET is shorted. So that is the reason why the first MOSFET is cutting down the 19 volts. It's not because the power rail is shorted, but because the second MOSFET is shorted. Okay, So let's put back this bigger one, the first MOSFET. Let's put back this one, which is good. So you have to understand these things. So let's look for another channel N MOSFET from the boards for space. I need another channel N MOSFET if I can get one. I need to look for another channel in Mosfets. Okay, I think I found one here. I just found one here. The board looks the same. Okay, let's replace that MOSFET quickly. Let's replace that MOSFET quickly. That should be better. So let's wait for the bulb to cool down. Our motherboard, I think, is now cooled down. It's now cooled down. So I think we can plug in the charger and check some voltage there. Charger plugged. You see? You now have light. That's a good sign. If we have light, it means my 19 volts power rail is now present. The 3.3, which is always on, is now present. and we have to try to power on the board. So you see why your first MOSFET in most cases is not driving the 19 volts. It's because check the second MOSFET. In most cases the second MOSFET will be shorted, like this one. What is that small MOSFET? This small thing is shorted. That is the reason why the first MOSFET was not driving power. But on some videos you see me jumping over the MOSFET. Obviously you get what you pay for. There are some customers which are pretty rude, they don't want to pay, so you get the service that you want or that you deserve. But those are all those things, they are shortcuts. But the best or the best solution, you have to replace the second MOSFET. Sometimes I'm jumping over from the first MOSFET to the current sensor, things like that. Yeah, your motherboard will still work fine. But this is job from another city. Obviously some attempts have been done, so we have to do this thing proper, just not to tarnish our image. Okay, so let's check now some voltages. Let's check some voltages. First MOSFET on the input 19.96, on the output is now outputting, you see, 19. Let's jump over the first MOSFET straight to the current sensor, 19.96. On any power supply here we have like 2 coils. We have some chips and some ceramic capacitor. I believe this is the 3.3 and 5 volts power supply. And on ceramic capacitors we do have 19 volts. So we can conclude that our 19 volts power rail is present. What is the next step? We explain this on lesson number 2, is to check the 3.3. 3.3, where do you check it? The easiest way is to check it on the power button connector. But we do have the ENE here, that's the startup chip. And this is some kind of new model with the BIOS inside, because I never seen a BIOS chip there. Oh, there's a BIOS chip here. Well, I can check on the BIOS chip for 3.3. On the VCC pin 0, 0, 0. So I believe this BIOS chip, because it's close to the processor, these are some kind of all-in-one processor with the graphics, chipset, PCH inside. So this is the memory probably for the PCH. So we will ignore that. We'll go and look for ceramic capacitors around the controller. There must be 3.3 volts. Okay, what do we have here? Check on the screen, 3.27. Let's look for a different ceramic capacitor here, 3.27. Let's look for the 30 capacitor here, 3.27. I checked the 3 ceramic capacitors, so that should be enough to conclude that our 3.3 volts power rail is on and is present, is working fine. The next step is to identify the switch button connector. We have this one, that's for the keyboard. This one is probably for the CD drive, hard drive, HDD. This one is for some USBs, network card. This one looks like for the mouse button. This one, that's for the speakers. Here we must have 3.3 there. Yeah, that the power on button is written on the board. The first pin 0, second pin 3.25 volts, third pin 3.26, fourth pin 3.28. So 3.25, 3.26, 3.28. In most cases, the power on button is taking lower voltage. So we have a 3. Let's check again. 3.25, 3.26, the third one 3.28. So the one with the 3.25, we must short it to ground. So how can we test this? We need the HDMI, obviously. We need the HDMI. Let's connect the HDMI here. Let's connect the HDMI. HDMI connected. And I need a tweezer to short this to ground, the second pin to ground. Second pin to ground. And it's working. I can't believe. Let me show you. Maybe I can show you. Maybe. Let me adjust my webcam once. You can see on the screen, boot device not found, because there's no hard drive there. Please install an operating system on your hard disk. F2 blah 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 blah. So our motherboard is working fine. You see? So this job is done. So our motherboard is working. I can't believe. You know, I fixed this, but I was more of doubting, you know, maybe it's not working or things like that, because this came from another computer repair shop. They checked, they gave their final conclusion that the processor is dead, but the fault here has nothing to do with the processor. This was the second Mosfet was shorted, and those are working as switches. So the first Mosfet will cut down the power in most cases. So that's the thing. That's the thing here. That's the thing. So the motherboard is working fine, and that's the problem in my country. There are very few technicians on the professional side. People that are trying to take money in town, but the knowledge is zero. Electronic knowledge there is zero. Trust me. There are very few who understand what's going on motherboards. So I'm happy because we help our customer from Bulawayo. Instead of selling him another motherboard, we just give him back the motherboard. Obviously, we have to check other things to see if everything is okay. But the most important part is our motherboard is working, and we don't have a dead processor here. So that's the reason why your first Mosfet is closed in most cases. If you don't have a shorted power rail, try to check the second Mosfet. The second Mosfet will be shorted, but not to ground, from drain to source, because drain, source and gate combination should not be mixed up. So don't get confused there. But if you see the second Mosfet not driving power, the 19 volts, if you check the first Mosfet is driving 19 volts on the input and output, the second Mosfet on the input you do have 19, but on the output of the second Mosfet you don't have power. That's a bad sign. Either you have a short to ground on any of the power supplies, or the 19 volts power rail is okay and we have something wrong on the 3.3 volts power supply, because the 3.3 volts power supply is always on even if your laptop is off. Obviously, the chances for that power supply to fail is higher as compared to other power supplies. So hope you understand. So I'll stop this video now. Remember those secrets for the input Mosfets in the future. So what can I say? Like, subscribe, don't forget to turn on the notification bell. See you on the next game, okay? Bye.